Alright gang, I'm going to do 29. I already did the upper sum, but I'll do the lower sum with you and then I'll just talk you through the upper sum real quick. So 29, we want to approximate the area of this graph on this domain, right? This is a domain for 4 rectangles. Now what I did real quick when I was first looking at this is I like to just draw the graph. I'm very visual. So here's the graph, 2x plus 5. And we want to find the area in between 0 and 2. So this is the area that we want to calculate. And we want to calculate that with 4 rectangles. So the first thing I did was I zoomed in on that area, okay? So we want to calculate the area from 0 to 2 using 4 rectangles. So that means you want to have 4 cuts in this. You want to have this cut into 4 equi-sized, in general, equi-width, I should say, rectangles. So the first thing you want to calculate is the width of each of these rectangles. Now this might be obvious here what the width is, but in general how you would do that is the width of the rectangle is the length of the interval, like how long, whatever length you're studying, so we're going from 0 to 2, over the number of subintervals, or they could use the word rectangles. So just be sensitive that the language could slightly modify. It could be number of subintervals or number of rectangles. So the length of the interval, you could think of that as x sub 2 minus x sub 1, or the right point minus the left point, okay? So if we do that over here, if we calculate the width of each of these, the width of one rectangle, okay, it's the length of the interval, or the right endpoint minus the left endpoint over the number they're asking for. So they're asking for 4 in this case, which means that the width of each of these is a half. So I go to 0, I jump a distance of a half. Here I jump a distance of a half. Here I jump a distance of a half, and then a distance of a half would get me there. So that's the first thing you want to do once you sort of get your graph down, is get the width of one rectangle and then figure out the increments on your graph. Okay, and then at each of those increments you want to go up and touch the curve. Now this case I'm going to do the lower sum using 4 rectangles. So my first rectangle plus my second rectangle plus my third plus my fourth. Remember, the area of a rectangle is length times width. We've already calculated the width. Each of these are a half wide. Each of these are a half wide. So we have to calculate the length. The length is going to depend on the height, or on the y value. The y value. Okay, let me move the function over here. F of x equals to 2x plus 5. So the length is going to depend on the height of the function, or the y value. Alright, so let's go ahead and start doing this. Alright, so the area, we're doing the lower sum here. So we've already agreed that each of the widths of these are 1/2. So let me just start by writing that down. Maybe let me be a little clear for you guys here. So again, what I'm trying to do is add the areas of each of these together. Alright, the area of the lower sum. Alright, so each of the widths for a rectangle we know are a half for each of these. Alright, now, since this is an increasing curve, this is an increasing function, the lower side is always going to be on the left. Let me say that even better. Since this is a strictly increasing function, the lower side is always on the left. So when you decide to figure out where the roof is on your rectangle, for this method we have a choice between using the left side as the roof or the right side as the roof. Either the left side is the roof or the right endpoint is the roof. Now since I'm doing the lower sum, I want the lower roof. So the lower roof will come from the left endpoint and not the right side. The right side would give me a higher roof. Alright, so my roof, so this is the logic you have to use. My roof is being created by this y value. This y value is being created by this x value. Alright, did you get that? So that means when I try to figure out my height of my roof, I have to use an x value of 0 in the function. So 2 times 0 plus 5 means that the roof is at a height of 5. So you put 0 into the function to find the height of the roof. Alright, so that's the area of the first one. The area of the first one is 5/2. Alright, now I'm going to go to my next one. Again, you can pick between the left and the right endpoint, but if it's an increasing function and we want the lower sum, we're always going to pick the lower side, because the left side will create the lower roof versus the endpoint of the right side of this rectangle, which would create a higher roof. We don't want the higher roof. Alright, so we're going to use this as the roof. This roof depends on this y value. This y value depends on this x value. So I have to use this x value in the function to find the y, which will create the roof. So I'll do 1/2 times, we're using an x value of 1/2 to create that roof. So 2 times 1/2 plus 5. I just like to crunch it out a little bit. So 2 times 1/2 is 1, 1 plus 5. So the roof, the height of the roof here is a 6. Alright, same idea. We're going to use the left endpoint on all of these. So hopefully you're getting the concept now. So the right endpoint would be higher, the left endpoint would be lower. The lower sum on an increasing function is the left side. So the roof depends on this y value, which depends on this x value. So we have to use this x value in the function. So the width is 1/2, and then the roof depends on, again, us using that value of 1. Oh, I wanted to write that up here. Alright, so 2 times 1 is 2 plus 5 is 7. So the height of the roof is a 7. Alright, now the last one, again, it's going to be the left side. It's going to make the roof. The roof depends on this y value. This y value depends on this x value of 3/2. So you put that in the function. 2 times 3/2 plus 5. The 2's cancel. You have 3 plus 5, so 8. Alright, now this is just me. This doesn't have to be you. I like to factor out my widths because they're always all the same. And that would give me this. So let's see, what do we got here? We have 11 plus 15, so that's 26. And we need to multiply that by 1/2. That would be 13. Alright, so that means that the lower sum, the area of the lower sum is 13. Okay, let's see, I'm at 9 minutes. Alright, let me see if I can then show you quickly the other one. And if it's too quick, you guys let me know. Oh, by the way, before we wrap this one up, remember the lower sum is too small because everything here was not included. And so I've underestimated the true area. It's an underestimate of the true area. Alright, now for the upper sum, you have to go above the curve. So on the upper sum, you want to do, instead of picking the left endpoint, you're going to want to pick the right endpoint on each of these segments. You're going to want to pick the right endpoint to make the roof. You're going to go above, right? This is called circumscribed when you're above the curve. Inscribed is when you're below the curve. So on this one, I've chosen all the values on the right side to draw the roof. So the only difference here is when I plug it in, so for the first one, instead of using 0 for the area, I've used a half, because this Y value determines the roof of the first one, so this X here determines this Y, so that's why I have a half here. For the second one, for this interval, this side is higher. So this Y determines the roof. This Y is determined by this X. This X is a 1. So that's why for the second, I put a 1 into the function. Alright, for the third one, same concept. It's the right side, so it's the 3/2 that will determine the roof on this. So that's the third one. I use 3/2 in the function. And the last one, the 2, determines the roof for this. So that's why I use the 2 in the function. Right, and then you could just see that I'm just crunching the numbers out. I'm just crunching out to get the Y values. So I get the Y values. And then you can see here I factored out the half. And then I added all this together. This was 30 times a half is 15. So what I found, so this is the upper sum. And again, if that was too fast, you guys let me know. It's the same process, it's just for the upper sum this time. So what we found was that the true area is somewhere in between the lower sum and the upper sum. So the lower sum is 13. I sometimes say true, but I think your book likes the word exact. So the exact area is somewhere in between our lower and upper sum. So it's somewhere in between 13 and 15 units. Alright gang, I hope that helped. I'll catch you. Bye-bye.